In this problem, from the figure shown, a uniform load of W equals 112 kN per meter is acting downward and supported by an upward uniform pressure of Q equals 48 kN per meter. We are tasked to find the maximum shear of the beam, the maximum moment of the beam, and the distance from the lip support where the flexural stress is 0. And to solve this problem, we construct our shear and moment diagram. So starting for the shear diagram, from this point and to this point, let's call this segment AB. It has an upward uniform load of 48 kN meter. So it would go up in a linear fashion since this is a uniform distributed load. The value here is equal to the area of this uniform load, that is 48 kN per meter times 1. So the shear at this point here is equal to 48 kilonewtons. From this point, B to C, notice that we have two uniform load, that is the 112 going downwards and a 48 load going upwards. So we can calculate the net load acting on this segment BC. That is equal to the downward load 112 plus the upward load, that is 48, and the net load that is acting here is 64 kN per meter going downwards. So we subtract 48 by 64 times the length of this segment, 1.5. We get our shear from B to C. It decreases to negative 48. And from C to D, it increases with a uniform load going upwards of 48 kN per meter on a span of 2 meters. This becomes 48 kN from C to D. And from D to E, we have a load going downwards that is 112 and an upward load of 48. So the net load acting there is negative 112 plus 48. That was negative 64 going downwards. So we subtract 48 from this point by the 64 uniform load times the length of the segment, that is 1.5. So it decreases from 48 to negative 48. And then it increases from negative 48 to 48 times 1 meter. This becomes 0. This is our shear diagram for this beam. Next, let's construct our moment diagram. But first, we need to find the distance from this point here to this point. This is 1 meters. And this point here, from B to C, the length of the segment, since B to C is 1.5 meters, and these two triangles are similar, therefore, the distance between B to this segment here, to this point here, is just basically half of 1.5. That is 0.75 meters. This one is 0.75. And from this segment C to this point, since these two vertical distances are equal, which means it will form similar triangle with the same horizontal distance. Therefore, these 2 meters will be divided into 2 equal parts. That is 1 meter here and 1 meter there. And then going from D to E, from 48 to negative 48, this would form 2 equal triangles. So just like before, this 1.5 meters will be divided into 2 equal parts. This one is 0.75 meters and this one is 0.75. And this one is 1 meters. Now that we have the value for shear, we're going to proceed solving for the moment diagram of the beam. And the moment is just equal to the area of the shear diagram. So going from 0, it increases parabolically because this is a first degree line. So it becomes a second degree line in the moment diagram. So from 0, we add this up to the area of the triangle here in segment AB. This is equal to 1/2 times base of the triangle, 1, times the height of 48, which is equal to 24. And from 24, it increases because we have a positive area here. And this point here of 0 shear is the maximum moment, where the slope of the moment diagram is equal to 0. We expect this curve to look like this. And the value here is equal to 24 plus the area of the triangle, that is 1/2. times the base of the triangle of 0.75 times its height of 48 equal to 42. And then it decreases because this area here is negative minus the area of the triangle, that is 1/2, times the base of 0.75 times the height of 48. It becomes 24 minus this area here, that is negative, which is equal to 1/2 times the base of 1 meter times the height of 48. It goes back to 0 at this point. Now it increases back because this area here is positive. We add 0 by this area of the triangle, that is 1/2 times the base of 1 meter times the height of 48. It increases back to 24. And from this point, D, to this point of zero shear, it increases back to 24 plus this area of the triangle, 1/2 times the base of 0.75 times the height of 48. That is equal to 42. And it decreases back because this area here is negative 42 minus the area of the triangle, that is 1/2 times the base of 0.75 times the height of 48. It decreases back to 24. And again, we have an area of negative shear, so this decreases back to 1/2 times base times height equal to 0. And we have our moment diagram for the beam. Now that we have our shear moment diagram, we can now proceed answering the problems. And for the first one, it is asking us for the maximum shear of the beam, and based on our shear diagram, it tends to occur at 4 points. Regardless whether the sign is positive or negative, that value is equal to 48. And it occurs at point B, C, D, and E. That is the answer for the first problem. And for the second problem, the maximum moment felt by the beam, based from our moment diagram, it has a value, highest value of 42. And it occurs at point between segment BC and segment DE. And for the last problem, the distance from left support where the flexural stress is 0, that is where the beam experiences 0 moment, to experience no bending stress. That is this point here. And it has a distance going from the left support. From segment AB, it has a distance of 1 meter, and segment BC has a distance of 1.5 meters. And from segment C to the midpoint of CD, there is a distance of 1/2 of 2 meters equal to 1 meter. So the sum of the distance is equal to 1 meter plus 1.5 meters plus 1 meter, which has a value equal to 3.5 meters. That is a distance from the left support where the flexural stress is 0, which is this point here. And these are our final answers.